Okay. Yeah, so where is that? So let me talk about the differentiation and integration first, right? And then I'm currently doing this chapter, which is motion in a straight line. So I have already talked about, yeah, I have already talked about, mm, okay, why this is not working. Okay, this pen is not working. So let me fix that problem and okay, let me fix this problem and then,
Okay.
yeah, okay, now it is working. Okay, so I have talked about the frame of references. So I am currently in motion in 1D, right? And in that, I have talked about the frame of reference. And then I talked about motion and rest state, right?
Okay.
And then I have talked about the properties or the parameter, the quantities which are associated with the moving body. So when a body is moving, so what are the physical quantities that we associate it with? So first one is this distance, right?
Yes.
And then you have the displacement, and then you have the speed, and then
Velocity.
velocity, and then acceleration. Okay. So I
Okay.
have completed this part up to speed part, and currently I am on this part, velocity. So to understand about this, we need two basic concepts. One is this vectors. And as you said, you already know vectors, so let us skip that. And the second one is this calculus. So in calculus, we learned about differentiation and then integration. So what is a differentiation? Okay, so let's say that I have a function y which is dependent upon x, right? Let's say that y
Okay.
is equals to x square. So if I take the value of x equals to 0, right? If I take the value of x equals to 0, my y is 0. So this point. And if I take x equals to 1, so y is also 1. So let's say this point. And if I take y equal to x equals to, let's say 2, so y is 4. So this is this point, right? So this is how it is varying, and in this way also. So you see that in a function you have one quantity which is in on the x-axis. So let's say this is x, and on the y-axis we have this function, right? So this is called the independent quantity, independent variable for a function, and this is the dependent variable on the y-axis.
Okay.
Dependent. So whenever you change x, your y will change,
Okay.
right? And
Yes.
when you calculate that how much your x is changing, right? So let's say that you have this point. This is x1 and this is y1. And let's say that you have this point x2 and y2. And you want to calculate the change, right? So this point is total y2, right?
Yes.
And this point is y1, right? So this
Yes.
point is y2 minus y1, right?
Yes.
And let's say that this is delta y. And this point is, so this point, this is x-axis, right? So this point is how much? This is x2.
X2.
And this is how much? X1, right?
Yes.
So if I calculate this thing, so this would be how much? This would be how much?
X1 plus X2.
No, total is x2. Total is x2. This one is x1. So this
Yes.
would be how much?
X2 minus X1.
X2 minus x1. Correct. So this is the change in x, right? And
Yes.
this is, let's say this is delta x. So if I calculate the change in y with respect to change in x, so that is called this, right? Change in y with respect to x. Okay. So this is
Yes.
the change in y with respect to x. But let's say that if I decrease this change of x, so if I decrease this change to a very small distance, nearly equals to 0. So this point comes in here. Okay. So this is the
Yes.
change delta x, and I bring this change very close. So I bring these 2 points very close, right?
Okay. Yeah.
So delta x will tends to what? 0, right?
0.
So when I do that, when I calculate delta x limit, when I calculate a limit where your delta x tends to 0, and then I calculate the change in y. So this is called the differentiation. And this is d by dx is denoted by differentiation. D by dx is differentiation.
So this is the formula.
Yeah. So this is the formula for the differentiation. Okay. This tells that how my y is changing with respect to my x. So if I change, so this is a very small change. This dx
Yes.
is, as you can see that this is very small. So how a
Yes.
small change in x can reciprocate or can change your y, right? So
Yes.
how changing a very small part of x would change your y? So this is called the differentiation. A very small change in y with respect to x. Is that
Okay.
clear?
Yes.
So this is what we call the differentiation, right?
Differentiation. Oh, yeah.
Yeah, and we have some known results that that I will tell you that. Yeah, so we have, let's say that y is algebraic function, algebraic or polynomial function. Okay, so for polynomial function, let's say that y is xn. So for xn, differentiation of y with respect to x would give me d by dx of xn, and this would give me nxn minus 1. Okay,
Okay.
yeah, so this is what we call, so this is for the polynomial function. Right.
Okay.
Let's take an example that if I calculate the differentiation of let's say 5, x to the power 5. Y is x to the power 5. So what would be dy by dx?
Dy by dx is
This,
equal to
yeah,
dx by 5
yeah, d by dx of, right.
power 5.
So we see that what is n here for the case of 5? Yeah. What is n?
N.
Yeah. So xn, the differentiation of xn, we know that this is n xn minus 1,
Yes.
where n is your power on x, right?
Yes.
So in the case of x to the power 5, what is n?
5.
5, right? So this would be how much? 5 in the,
5.
yeah, 5 and x 5 minus 1, right?
Yes. Yes.
So dy by dx would be how much? 5x to 4. So this is the differentiation of x to the power 5, right?
Yeah.
And if let's say that fx x to the power 7, so what would be dy by dx?
Dx 7
Yeah, by dx. So
by dx.
this is very important. D by dx we always write. So this would be how much?
7x 7 minus 1.
So this is simply 7x6, right?
Yes.
This is the differentiation. Okay, this is the
Okay.
differentiation of a polynomial function. And
Okay.
let's say that yes, hello Akib, assalamu alaikum.
Assalamualaikum, sir.
Walaikum assalam. You were not present in the previous two classes. What happened?
Sorry, sir, I was busy.
Oh, you were.
Sometimes my net was not there.
Arey,
And package, it was finished already.
oh, okay, okay. So yeah. Okay, so Amna has just joined, so I'm just talking about the what we have learned so far, right? So this would
Yes, sir.
be, yeah, this would be revision for you.
Yes, sir.
Okay, so this is about the polynomial function. Understood, Amna? So
Yes, sir.
you tell me that if y is equals to root x, right? Then what would be dy by dx? Can you find out?
Sir,
Yes.
actually, my net, it will be not good
Yeah.
now, like after now. So I won't be able to open my mic. So
Good
please
Okay.
evening,
help.
sir.
Yeah. Good evening, Isha. Yeah, that's okay. That's okay. That's okay. Akib.
Okay, sir.
Mm.
Thank you.
Yeah. Good evening, Rishta. How are you?
I'm good, sir. How are you?
I'm also good. Okay. So yes, Amna. What?
Dx root x divided by dx.
Yeah. So what is the power of x in here? What is the power? If we have root, then what is the power?
1.
So if I have y equals to x, then what is the power?
1.
Yeah. So these are not the same, right? So square root, what is the power? How do we represent the square root in powers? Yes.
0.
So x to the power 0 would be 1, right? So this is x to the power half, right? Root x is x to the power half. Just remember that what is root 4? This is 4 to the power half, right? So that is why we write this as 2 square and half. So we get 2. Root 4 is 2. So root x is x to the power half, right, Amna?
Okay.
Yeah, so we now know what is the power. D
Yes.
by dx of x to the power half. Right, so what would be this? Yes, what would be?
X minus 1 by 2.
Yeah, so first we write the power beside the function. So half would be there, right? Half will come down from the power.
Okay.
And then we write x, and then we take minus 1 from the power. So this is the general formula, right?
Yes.
For xn, this is the general formula. So similarly, n was half. So we took half in here and then in power we subtract 1. So half minus 1. So this would be half, and half minus 1 is how much? Minus half. So this would be 1, and this is in the negative power. So this would come in the denominator and the power would become positive.
Positive.
So then this x to the power half, we know this is root x. So differentiation of y is equals to root x would be how much? This would be 1 by 2 root x.
1/2.
Yeah, so let us stop this at here, and let us go back to what because Akib and Rishita have come. So yeah, let me just start the topic which I am doing currently, and I will talk about the rest of the. I will take this in the backup class. Okay, Amna.
Okay.
Yeah. So, or what we can do is that Afaf and who has not come? So Afaf and who is the other guy? Rishita. Who is the other one? Yes,
Sir, yeah, sir.
Yasir. Oh, Yasir is in the NEET batch, not in this batch, right?
Yes, sir.
So who is? I guess Hasib is in. Hasib not. Who's the other guy? Akib, do you remember? So you are here, Rishita, and one is yeah. Who's the other one? Okay, no one. We only had three people. Okay, so let's wait for Afaf and then. Okay, so Amna, we can continue from here. Let's wait for Afaf to join and then yeah. Okay, so this is about the polynomial function. Okay, Amna.
Yes, sir.
Then we have the trigonometric function. Okay, so what is the differentiation of a trigonometric function? So we have let's say sine x or cos x. Right. So what is y is equals to sine x? So what is the differentiation of sine? This is simply what? D by dx of sine x, and this is simply cos x. So this is the known result. And if y is cos x, so differentiation of y with respect to x, which is d by dx of cos x. This is how much? Rishita, this is
Sin x.
sin x, but yeah, Rishita, okay. What is the differentiation of cos x, guys? Do you guys remember? Or you guys have forgotten? Negative sin x, yes. So negative sin x. This is the differentiation of cos x. Okay, Amna.
Why negative, sir?
Why negative? This is a known result that it comes. So this you will learn. Do you have maths in your? Uh,
No.
you don't have maths. So don't worry about the proof, because then we need to talk about what is fx plus h minus fx divided by delta h, right? Or delta x, which is h. So then we have lots of problem if you want to derive this. So this is a known result, and just remember this. This is
Okay.
limit h tends to 0. Then I will have to talk about the limit and then differentiability. So that would be hectic. Yeah, but for this part, just remember that this is the result. Okay,
Okay.
yeah. And then we have this exponential function. So for exponential function, y is represented by ex. Okay, where e is 2.71. Okay, and yeah, and the differentiation of ex is simply ex. So this is simply ex. Okay, and then you have this logarithmic function. So for logarithmic function, let's say y is equals to log x. So the differentiation of log x is simply d by dx of log x, and this is simply 1 by x. Okay, so these are the four functions that we need to remember. One is this algebraic function, right? For the algebraic function xn, the differentiation is nxn minus 1. And then you have this trigonometric function, right? Sin x cos x. So the differentiation is this. And then you have this exponential function. So the differentiation is this. And then you have this logarithmic function. So these are the four special functions that we need to remember for our purpose, right? And
Mm.
where do we use this differentiation? So this we will use in the speed and velocity and acceleration. So yeah, this comes in handy when we talk about speed, velocity, and acceleration of a moving body. Okay,
Mm. Okay.
so let us come to what we were doing in motion in 1D, right? Okay, so let me give you a quick recap, right? So we did what we have done so far is that we have talked about speed, we have talked about distance and displacement. Right, so we have talked about distance, which is the, yeah, this is chapter 3, I guess. This is chapter 3, motion in a straight line.
Okay.
Yeah, yeah. Akib, you were not in the first class also. Hmm. Okay, then what I will do is that, okay, then what I will do is that I will take a backup class for you and Amna, because you guys were not, yeah, you know this chapter. Okay, then this is good. So distance, this is let's say that you have this A and B point, right? And then you follow this path. So this, let's say that this AB arc, yeah, okay, okay, okay. So this is the total path length. This is the distance. So this is the distance. Okay. And displacement is what? I'm just quickly recapping. I'm not talking about the whole. So I'm not talking about in detail. I'm just talking about what are these. So displacement is the shortest path between 2 points. Okay. And then we have this is speed. So speed is what? This we all know from our Yeah, from our ninth and 10th classes. This is distance by time. Okay. And then we have three kinds of speed. So, Rishida, did you try that problem? Yeah, Rishida.
Yes, sir.
So, what did you get? What did you get? What was the average speed?
So, which problem are you talking about? The d
Yeah,
by d?
I divided the journey in three parts. So this part has V1 speed, V2 speed, and V3 speed. This was the question, right?
Yes, sir. I didn't get it.
Ah, you didn't get. Okay, so we will talk about that. Okay, so we will talk about that. Yeah. So yeah, so we have three kinds of speed, right? Mainly we have two kinds. One is the uniform speed, right? And then we have this non-uniform speed. And this non-uniform speed is of two types. So first is this average speed, and this is what? This is the instantaneous speed. Okay. So when what we do is that what is the uniform speed? When a body covers equal distance in equal interval of time, right? So then that speed is called uniform speed, right? So let's say that yeah. So let's say that we have A, B, C, and D point. And let's say that we have this distance is, let's say, 1 and let's say 2 second, 3 second, and 4 second. So let's say that a body covered 2 kilometer and then 2 kilometer and then 2 kilometer. So you see that a body is covering same distance in 1 second. Right. So what is the velocity here? Velocity is 2 by 1, so or speed. So speed is 2 kilometer per second. In here, speed is also 2 kilometer per second. And in here, speed is also 2 kilometer per second. Right. So for the whole journey, the speed is uniform. This is called the uniform speed when you cover equal distance in equal interval of time. Right. And then you have the non-uniform speed. So let's say that you are at you cover some distance from A to B and then C to, let's say, D, and yeah. So let me so A and B and C and D. So let's say that this is 1 second, this is 4 second, this is 9 second, and 1 3 4 4 3 7. So 7 second and 10 second. And then let's say that you cover 2 kilometer here, then you cover 4 kilometer here, and then you cover some 6 kilometer. Right. So you see that your velocity or your speed at this point is how much? Speed is 2 by 3 kilometer per second. And in here, your speed is how much? Distance by time. So 4 by 3 kilometer per second. And in here, your speed is how much? 6 by 3 kilometer per second. So you see that in here, I have a different speed, right? Let's say speed 1, this is speed 2, and then speed 3. So you see that my speed is changing. So this is called the non-uniform speed, whenever a body covers an equal distance in equal interval of time, right? So this is called non-uniform speed. And then you have this average speed and instantaneous speed. So let's say that if I want to calculate what is the speed at this point B, right? So speed at this point B is how much? 4 by 3 kilometer per second. So this would be called the instantaneous speed at P. Whenever I am calculating the speed at certain point, right? So then that is called the instantaneous speed. Is that clear, guys?
Yes, sir.
And then what is the, yeah, and then what is the average speed? So average speed is the speed throughout the journey, right? What is my speed throughout the journey? So that is calculated by the total distance by total time taken. Okay. So how much is the total distance? 2, 4, 6, 12 kilometer. And how much is the time? So 9 seconds, right? Because 1 to 4, 3 second, 3 second, 3 seconds. So 3 plus 3 plus 3, 9 seconds. So 12 by 9. This is how much? 3 and this is 4. So 4 by 3 kilometer per second. This is my average speed, right? The speed throughout the journey. Okay. Is that clear, guys?
Yes,
Yeah.
sir.
Yeah. So Afaf has not come, right? I thought that while I will be doing the recap, Afaf would come, but she has not come yet. Okay. Then we learned about the instantaneous speed, right? And average speed, we can also calculate the average speed by this formula also. So average speed is also delta x by delta t. This we will learn. So one is this: whenever you are given some right some journey, right, and you know all these different speed, then you apply this total distance by total time. But whenever you are given in the parametric form, whenever you are given x as a function of t, right, then you calculate delta. Okay. Yeah, so I will talk about that. Right, I will talk about that. So whenever you are given the parametric form, then how can you calculate average speed, and then how can you calculate the instantaneous speed? Okay, so you calculate the average speed by this, and you calculate the instantaneous speed by dx by dt. Okay, so these are the two ways that you calculate the average speed. One is by whenever you are given this form. So let's say that I have given a body is moving in the form which is as below. So x is 3t square plus 4t plus 5. X is this. Okay. Then, so Rishita, you tell me that average speed is calculated at some point or through the journey,
Throughout the journey.
throughout the journey, right? So, yeah. So if if I am given this question, this type of question, so I cannot calculate the total distance by total time relation, right? If I want to calculate the average speed, so I cannot use this formula, right? Right, Rishta?
Yes, sir.
Yeah, so whenever I am given this kind of question, so in the question they will talk about speed. So is this a uniform speed or non-uniform speed? This is what
Uni-
kind?
Uniform speed.
A uniform. So is my distance is same for all the time interval? Yeah,
No,
right.
non-uniform.
So
Yes,
this
sir.
is a non-uniform, right? So then the question would be that what is speed from 0 to, let's say, 3 seconds, right? So I am given some journey, right? So if I am given this, then what should I calculate? Instantaneous or average? Yes,
Average.
average speed. So in this case, I need to calculate the average speed. And if they want us to calculate that speed at t equals to 4 seconds. So this is time is given, right? So this is what speed? Average or instantaneous?
Instantaneous.
Instantaneous, right? So whenever this kind of question is given, the question in parametric form, x as a function of t. So for the average speed, these information would be given, and for the instantaneous speed, only the time would be given. Is that clear, guys? Yes. This is just identifying the problem that what we should calculate, average or instantaneous.
Average.
Yeah. So, and we know that average speed is what? Average speed is what will we write? Total distance by total time or this one? Delta x by delta t. For the parametric form, we use this. Okay. I will talk about the delta in a moment. Okay. Yeah. So this is what we will use. And for the instantaneous speed, this is what we will use. Okay, so now let us do this problem first. First, what is delta? So delta is, let's say I calculate delta of x. So this would be x final minus x initial. Delta is called the change in x. Okay, change in x. So let's say that if I want to calculate delta y, so this would be simply y final minus y initial. Okay, is that clear? So let's say that I am at this point x1, which is, let's say, 2, and this is x2, which is, let's say, 5. So delta x would be how much? X2 minus x1, which is 5 minus 2, which is 3. So this is the delta. Yes. So this is the delta. Okay. Okay. Now let us focus on this question. So x is how much? 3t square plus 4t plus 5. And we need to calculate average speed from t equals to 0 to 3 seconds. So what is t1? Average speed would be what? Average speed would be delta x by delta t. Right. This is how my time is changing and my speed distance is changing. So average speed would be delta x by delta t. Right. Yeah. So what did I write in? No, no, no. So we want to calculate the speed from 0 to 3 seconds. So they want us to calculate the speed throughout the journey, right? So they want us to calculate speed throughout the journey, not at some point. So if they have asked you about, let's say that what is x or what is speed at 4 seconds. So then we can use the instantaneous speed. Yeah, I'm talking about the x. Okay. Yeah, so you are saying that can we use dx by dt? Yeah, you are saying that. Yes, so dx by dt gives you what? Akib, this gives you what? What kind of speed this gives you? Yes, Akib, what kind of speed this gives you? So you see that this is a non-uniform motion. So what kind of speed this will give you? Rishita, what kind of speed this will give me?
Instantaneously.
Instantaneous speed, right? So if I use this dx by dt, this will give me instantaneous speed, Akib. Okay. For average speed, we need to calculate delta x by delta t. Yeah. For average speed, I need to calculate delta x by delta t. Is that clear, Amna?
Yes, sir.
Okay. So now we need to calculate what is delta t. So average speed would be x2 or x final minus x initial divided by t final minus t initial. Okay. So we know what is t initial. T initial is how much? 0. T final is how much? 3 seconds. And x initial would be how much? X initial would be x of t initial, right? So this would be how much? 3 into 0 square plus 4 into 0 plus 5. So x initial would be 5. It's a meter per second. Okay. And you guys calculate me what is x final. So calculate and tell me. Yes, 44. So, Rishita, are you getting 44 also? Yeah, Rishita and Amna, what did you guys get?
So even I got 44.
You also got 44. And Amna, what did you get? Yes, Amna, what did you get? Or do you have a doubt?
35.
35. Okay, so let us check because majority is 44, right, Amna?
Yes.
So, yeah, so let us calculate. This would be 3 into 3 square, right? And then 4 into 3 plus 5. So this is 9, 27, this is 12, and this is 5. So this is 39 plus 44. Right, Amna? So please check your calculation.
Okay, sir.
Yeah. So now we know x final, we know x initial, we know t final, we know t initial. So what would be the average speed? Average speed is 44 minus 5 divided by 3 minus 0. So this is 39 and 3, right? So 13, 13 meter per second. So this is the average speed. Average speed is 13 meter per second in the journey from 0 to 3 seconds. Right. So whenever we are given the parametric form, parametric meaning x as function of time, distance as a function of time. So we will use this formula of average speed. Is that clear? Yeah. Is that clear to you guys? Rishida, Akib, and Amna?
Yes, sir.
Yeah. So whenever they ask you about the speed throughout the journey, we talk about the average speed. And now the other question was that what is the speed at t equals to 4 seconds? So at instant we are calculating. At t equals to 4 we are calculating. So this is instantaneous speed. Okay, so we need to find out what is the instantaneous speed first. So the second question was x is 3t square plus 4t plus 5. So we want to calculate speed instantaneous. So this would be dx by dt, right? So that this is where this differentiation is important. Okay. So this would be how much? D by dt of 3t square plus 4t plus 5. So yeah, Amna, you know, you don't know the rule about differentiation. So let us bear with us. Let us just accept the results, and then when I take the backup class, so then you would be able to understand. Okay. Yes. Yeah. So what is the difference? What would be the differentiation? Akib and Rishita, you calculate and tell me the answer. Yes, you guys calculate and tell me the answer. Okay. Yes, Rishita, are you calculating also?
Yes, sir.
Yeah, please calculate and tell me. Yeah. Uh, yes, correct, Rishita, correct. So, yeah, Akib, what are you getting? Oh, okay. So let me solve this, and you check your answer, Akib. So this would be d by dt of 3t square plus 4t plus 5, right? So we know that we can separately find the differentiation. So this would be d by dt of 3t square plus d by dt of 4t plus d 5 by dt. What is the differentiation of a constant term, Akib? Yeah, do you remember? Huh? Differentiation of constant term. This one, differentiation of constant term. Yeah, so please revise, Akib. Differentiation of constant term is zero. Differentiation of constant term is zero. Okay. And yeah, and then we have this 3t square. So in this 3t square, we have a constant multiplied. So this is taken outside. And then we calculate the differentiation of t square. And similarly, 4 is taken outside, so dt by dt. So dt by dt is 1. And Amna, what is the differentiation of t square? What is the differentiation of t square? So what is the power here, Amna?
2.
2, right? So power is taken down, right? So power comes in here, and then 1 is subtracted from the power, right? This is the differentiation that we learn. And plus 4, this is 1, so 4. So this is 6t plus 4. This is the instantaneous speed. Is this clear, guys? Yes, is this clear, guys? Okay, then they are saying us to calculate the speed at 4 seconds. So we know that speed is this. V is 60 plus 4, and they want us to calculate V at 4. So this would be 6 into 4 plus 4, which is 24 plus 4, which is 28 meter per second. Right. So this is the instantaneous speed at t equals to 4 seconds. Is there any doubt, guys? Yes. Is there any doubt? Okay, so you guys quickly note down this problem, right? Uh, yeah, this problem you guys note down, and then I will start with the velocity one. So this I did in the previous class. Can you guys be regular? Otherwise, I have to repeat again and again, right? Yeah, this part already we did. Only this portion we didn't do, right? Rishida? Average speed for the parametric form we didn't do, right, Rishida? Yes, am I audible, guys? Rishida, can you hear me?
Yes, sir.
Yeah, so this part we didn't do in the previous class, right?
No, sir.
Yeah, please note it down. So whenever you guys need me to scroll down the screen, you guys have finished. Rishita and Amna, finished.
Yes, sir.
Yes, sir.
Yeah, so please note it down. I have written here and there. So yeah, this part is not needed. Right, you guys note down for me. And whenever you have completed, please tell me. Oh, what is happening? Yes, should I scroll down, guys? Yes, Rishita and Amna, done.
Yes, sir.
So whenever you guys have finished, please tell. Okay, so Rishita and Amna, finished.
Finish, sir.
Yes, sir.
Okay, so let me, yeah, just remember this flow chart. You have speed, right? Then you have this uniform speed, and then you have this non-uniform speed. So whenever you cover equal distance in equal interval of time, that is uniform speed. So this is distance by time. And then for the non-uniform case, you have average speed, right? So this is what? This is total distance by total time taken, right? And then you have this instantaneous speed. So this average speed is speed throughout the journey. So this can be always also calculated with delta x by delta t when parametric form is given, right? And this is simply what? This is dx by dt. So just remember this flow chart. This okay. So now we have the next topic, which is the velocity, right? So do you guys want to note down this part? This we have done already, so no need to. Okay. Yeah. So then we have this next topic, which is velocity. What is velocity? It is the displacement covered in time, right? So what is this velocity is, let's say displacement, right? R by T. Okay. And how do you calculate? Yeah, so let me write this way. And this is what? This is a vector quantity. And its SI unit is what? Is meter per second. Okay. So as you can see that this is a vector quantity. So what part would be also important? Yes, Rishida. As this is a vector quantity, so what part would be also important?
So the direction and
Yeah, direction. So magnitude is it would be important as well as the direction, right? So magnitude as well as direction is important, right? So if we are in chapter what? Motion in one dimension, right? So let's say that we are moving in this way. This is motion in one dimension, right? So our speed or our distance would be equal to magnitude of distance would be equal to displacement, right? If I am moving in the same direction in 1D, so distance is equal to displacement, right? Magnitude. Is that clear?
yes, sir.
So, so speed and velocity is equal in one dimension. Whenever we are not changing the direction, okay. So if we are going in the same direction, we are not returning back. If we return, then velocity and speed will change. Speed would be different and velocity would be different, right? But whenever we are moving in the same direction, then magnitude of speed and velocity would be equal. Is that clear? Yes. Yeah. So let's say that if I move 3 kilometer, right, and then again 4 kilometer, right, in the same direction. So what is my displacement, guys? My displacement or what is my distance? Distance is 7 kilometers. Yeah, distance is 7 kilometers. And what about my displacement? What is my displacement? Yeah, this is also 7 kilometers. Right. So whenever I am in the same direction in one dimension, then my distance would be equal to displacement. Right. And let's say that if I move in this direction 3 kilometer, and let's say I move in this direction 4 kilometers. So my distance would be AB plus, let's say this is BC. Distance would be how much? 3 plus 4, 7 kilometers. But what would be my displacement? My displacement would be not this. My displacement would be the shortest path, right? So this would be 5 kilometers. So you see that whenever I change the direction, my displacement changes, right? So then distance is not equal to displacement. But whenever I am in the one-dimensional motion, then my distance and displacement are equal. Is that clear? Yeah, is that clear, guys? Okay, so this was one thing that I wanted to tell. Okay, and this velocity will have in we are motion in 1D, right? So this will have a same chart again. So we have velocity, right? Then it will also have two kind of motion. So uniform velocity, right? When a body covers equal displacement in equal interval of time. And then we have this non-uniform velocity, right? So whenever the magnitude of displacement or magnitude or the direction, whenever a body changes its direction or whenever a body has a different magnitude of displacement, then that would be called a non-uniform velocity, right? And then it has also two parts. One would be one would be what? One would be average velocity, and this is instantaneous velocity. Okay, so uniform velocity definition would be the same as what the speed one. Whenever a body covers equal displacement in equal interval of time, and whenever a body covers unequal displacement in equal interval of time, right? And for the case of average velocity, we calculate average velocity as total displacement by total time taken. So in the place of distance, we have displacement. This is the only difference. But if we are in one dimension, then this is also equal. So average velocity would be equal to average speed. Okay. Yeah. And then we have this instantaneous velocity. Okay. So what is this instantaneous velocity? Instantaneous velocity would be v, which is dx by dt. So this is the instantaneous velocity. Is that clear, guys? Is this clear? So I will not write about the definition, right? I will not write about the definition because the definitions are the same. Only in the place of distance, the displacement comes. This is the only difference. Okay. And whenever we are in one dimension, so the speed and the velocity are the same. If the direction is not changing. If the direction would change, then the velocity and the speed would be different. Okay. So let us take an example of let us take an example of yeah. So let us take an example of this thing. Or do you guys want to note down this part? But this part is same as the speed one.
Sir,
So yes,
what is vector R?
vector r. So this is the displacement vector,
Okay.
right? This is the displacement vector. Okay, so Yeah, let me talk about the average velocity and average speed when they are not same. So let's say that we have a body is traveling from A to B and with 4 kilometer per second, right? And then it turns back. It turns back and move with let's say uh, 10 kilometer per second, right? In let's say 5 seconds. So this is the total time. What is the average speed and average velocity? So only you see that whenever the direction changes, so then you need to just you need to be careful about the average velocity and average speed. Whenever the direction are the same, then average speed and average velocity is the same. Okay, so in this question you have A and B point, and first the body travels from A to B with 4 kilometer per second, right? Or not? I should not write about the this. Let's say write about the distance 4 kilometer, and this is 10 kilometer. 10 kilometer. Okay, so then what is the average speed and average velocity? So a body is covering 4 kilometer in this direction. Okay, and then it changes its direction and then it is moving in this way 10 kilometer. Okay, so average speed would be what? Average speed would be delta x by delta t, right? Is this clear, guys? Is this clear? So delta x would be simply x final minus x initial by time is how much? T final minus t initial. So this would be simply x final is how much? 10 kilometer minus x initial is 4 kilometer divided by total time is t final minus t initial is 5 seconds. So 6 by 5 meter, or let's say kilometer per second. This is the average speed, guys. Okay. What about the average velocity? So average velocity would be what? Average velocity would be delta x hat, or let's say vector divided by delta t, right? So this is what? Direction. How can I write xi? Xi hat is how much? And x final hat vector is how much? So Rishita, you tell me that what is x final vector? Yes. Let's see that you guys remember the vector classes or not. Yes. What
So the
is
magnitude,
yes?
the magnitude.
No, the vector x final vector. So this is x final vector. What would be the vector?
10 I cap.
Oh, so just see the direction. You are nearly correct. This is,
Minus 10.
yes, absolutely right. So minus 10. Right. And Akib, you tell me what is initial? Yes, what is initial? Uh, what is xi initial? 4, but what? We have a direction also. We have a direction also. Yes, 4 I can. Yes, absolutely right. So 4 I can. Is this clear to you, Amna?
Yes, sir.
So this would be x final vector minus x initial vector divided by t, right? Which is how much? 5. So this would be simply x final vector is minus 10i minus of this 4i, right? So by 5, which is minus 14 by 5i, right? So this would be minus 14 by 5, right? So what would be the magnitude? The average velocity magnitude would be simply, if I take the positive sign, so this would be 14 by 5 in this direction. In this direction. Right, guys? Is this clear, guys?
Yes, sir.
Okay, so you guys note it down, and then we will talk about the next topic. So this was only the difference between average velocity and or the speed and the velocity. But we are in one dimension, so this would be the same. Average or if we are not changing the direction, then speed and velocity would be the same magnitude. Yes, any doubt up to this point, guys? Any doubt? Okay, Rishita and Amna, noted up to this point.
Sir, I have done.
Done. Rishita, what about you? Yes.
Yes.
Okay, so please note it down here also. Yes, Rishita and Amna, finished?
Yes, sir.
Okay. So then let us go into the next topic, which is the acceleration. So acceleration is what? It is the rate of change of velocity, right? With respect to time. So whenever we are saying about rate, so that signifies what? This would be with respect to time only, right? Is this clear, guys?
Yes, sir.
Yeah. So Okay, so this is it is the rate of change of time. Okay, then we have what? So acceleration is what? This is mathematically, how do we represent this? This is v minus u by t, rate of change of. So this is where v is what? Final velocity. U is initial velocity, and t is total time taken. So I can write this as t2 minus t1, but let's say that I start from 0. So t is total time taken. Okay, and this is also a vector quantity. So this is also a vector quantity, right? And its SI unit is what? SI unit is meter per second square. Okay. Yeah. So this is about acceleration. Okay. Is this clear, guys?
Yes, sir.
Okay. Then again, we have the same diagram. Again, did you guys note down this part? Yeah. So again, we have the same diagram. So we have acceleration. It is also of two types. One is this uniform acceleration, and then we have this non-uniform acceleration. Okay. And again, non-uniform acceleration is of two types. One is this average acceleration. And then we have this instantaneous acceleration. Okay. So as you can see that the definition would be the same, right? So when the change of the velocity in all of the journeys is same, right? When we have equal change in velocity in equal interval of time, then that would be called what? That would be called a uniform acceleration. Okay. When we have equal change in velocity in equal interval of time. So let's say that at this point, let's say that we start at let's say t equals to 1 second, right? Or let's say this is t equals to 0. The initial speed was let's say in here this was v1 was 0 meter per second. Okay, in here, so this is 2 seconds, right? And v2 is let's say this is 1 second, and this is 2 meter per second. And we come here, so this is 3 seconds, and in here this is v2 is 4 seconds, 4 meter per second, right? And we come here, and so this is v3. V4 is how much? 6 meter per second. Okay. So in here, in here in this journey, what is the acceleration, guys? V minus u by t2 minus t1, 1 minus 0, right? 2 minus 0, 2 minus 0, 0. Why this is 0? So 2 by 1, which is 2 meter per second square. This is A1. And in this journey, what is the acceleration? So this is 4 minus, oh, this is 2. And this is 3. So this is t is 0, right? But we have from here to here, we are calculating t2 minus t1. So I should write it here, change, right? So t2 minus t1. And we always take t1 to be 0. We start from, time starts from 0, right? Yeah, so if time starts from 0, so this would be simply v minus u by t. So that is why I have written this. Okay. Okay, so yeah. In here, what would be the acceleration? V3 minus V2, which is 4 minus 2 by, this is how much? 2 minus 1. So again, 2 by 1, which is 2 meter per second square. Right. And then we have for this journey A3, which is 6 minus 4 divided by 3 minus 2. So again, we see that this is 2 by 1, which is 2 meter per second square. So you see that the change in velocity from this point to this point, from this point to this point, this point to this point, change in velocity is same. Right, guys? So change in velocity is the same. So what would be, what this acceleration would be called? Yeah, so this is called the uniform acceleration. Is that clear, guys? Is that clear?
Yes, sir.
Yes, sir.
Okay, so you guys write about this. You guys note down this, and then we'll talk about the next part. Yeah, whenever you guys have noted down, please tell me. Yeah, Rishita and Amna, done.
Yes,
2
sir.
minutes, sir.
Okay. Okay, so then what we have in here, let's say we have A point, B point, C point, and D point. So let's say at, again, t equals to 0, we have V equals to, let's say, 0 meter per second. And then what it comes here, t equals to 1, and then in here velocity is let's say velocity is 2 meter per second. Okay, and then it comes here and the velocity becomes let's say 6 meter per second. Okay, and then it comes here t equals to 3 second and the velocity becomes let's say 14 meter per second. Okay, so what is the acceleration between this point? This is 2 minus 0 by 1 minus 0. So again 2 meter per second square. What is the acceleration from B to C, Rishita? Yes,
3 meter per second square.
right. So 6 minus 2 and divided by 1. So 3, how did you get 3?
4 meter per second square.
Yeah, so 4 meter per second square. This is A2, right? And then you have in this journey, you have, so what is the acceleration, Amna, in this journey? Yes, Amna, what is the acceleration in this journey?
8 meter per second square.
Yeah, so this would be 14 minus 6 by 3 minus 2, which is 8 meter per second square. So you guys can see that the acceleration is changing, right? So this is called the non-uniform acceleration. Okay. So whenever you have unequal change in velocity in equal interval of time, so that is called the non-uniform acceleration. Okay, so let us write the definitions, and yeah, in the next class we will do some question about that. Okay, so uniform. Did you guys understand about uniform and non-uniform acceleration? Is that clear now?
Yes, sir.
Oh,
Yes, sir.
yeah, so uniform acceleration. When a body has equal change in velocity in equal interval of time, then that acceleration is called uniform acceleration. This uniform acceleration is very important, right? So you have learned the kinematics equation in your 10th class, right, guys? You know the kinematic equation. S equals to U plus ut plus half at square, V is U plus at, V square minus U square is 2A. This you know, right? Yeah, so this is for what kind of acceleration? This is true for what kind of acceleration?
Uniform.
Yeah, whenever you have a uniform acceleration, then your all those three equation of motions, right? Equation of motion. So those three are called equation of motion. So those three are valid only for this uniform acceleration. Okay. And then you have non-uniform acceleration. So when a body covers, when a body has unequal change in velocity in equal interval of time. Then that is called non-uniform acceleration. Okay, so you guys please note down this part, and the question on average acceleration and instantaneous acceleration we will do in the next class, and we will also see that how can we prove those kinematic equation using differentiation and integration, right? So proof of kinematic equation was done in your school, right?
Yes, sir.
Yeah, using that differentiation and integration. So the
Yes,
next
sir, I completed writing it.
oh, you have completed. No, Akib is saying that lower the screen. So oh, he said
Sir,
lower
can
the
I
screen.
leave the meeting because I completed it?
Yeah, okay, then yeah. Bye, Rishita. Bye.
Thank you, sir. Bye, sir.
Bye. Yes, Amna and Akib, did you guys note this part?
Yes, sir.
Okay, so what I will do is that I will take a backup class for Amna and yeah, Akib, you also, and you guys please be regular from the next classes. Otherwise, yeah, you will miss certain topics. Okay, okay, guys. So see you in next Saturday, guys. Bye, guys. Bye.
Sir, when is the next class?
Yeah, the next class will be on Saturday.
So Sunday and Saturday.
Yeah, Saturday and